Okay, shall we start? So neutrinos, there are two fundamental particles. One is neutrinos, next one is Higgs boson particles. So why we are calling those particles as a fundamental particles? We can call it as a fundamental particles. Next one is elementary particles, because they are the basic particles that exist in nature. Okay. They are very basic in nature. So we know that. So atom consists of what? What is that? What will be there inside the atoms? Electrons, protons, neutrons. So where these electrons, protons, and neutrons are present inside the atom? Electrons. So this is an atom. Atom consists of nucleus. Nucleus consists of protons plus neutrons, and electrons revolves around the nucleus of an atom. Electrons revolves around the nucleus of an atom. This is what. So we know that nucleus of an atom consists of protons plus neutrons and electrons. So if there is a question how these electrons, neutrons, and protons are formed, how they are produced. So have you read anywhere this, like these electrons, protons are produced? Have you read anywhere regarding to the mechanism of formation of electrons, protons, and neutrons? We know, we have a knowledge so far, whatever the knowledge we have is. So we know that there exist electrons, protons, and neutrons inside the atom. That is the thing we know that. And how they are formed means the fundamental theories are coming up. Okay, now, and there are fundamental particles, like neutrinos are the fundamental particles. Next one is Higgs boson is the fundamental particles. Like this, in our universe, there are certain fundamental particles which is responsible for carrying a force, means that we call it as a force particles. And next one is responsible for sharing of mass from one particle to the another particles. Okay, now, so yesterday I told you that I made you to write that. What is that means? There are in nature there are four fundamental basic forces. Okay, now what are those four fundamental basic forces means? Strong nuclear force, weak nuclear force, electromagnetic force, and next one is gravitational force. So these four basic natural forces are because of these fundamental particles. It may be force carrier particles. What actually is force carrier particles? What actually is mass carrier particles? We should know this. Okay, friends. And first I will give you information regarding to this fundamental particles. Then I will give you information regarding to this neutrinos and Higgs boson particles. Got clarity, friends? Okay, now, so that is that. So these neutrinos and next one is Higgs boson are the part of these fundamental particles. Have you heard about these photons? Light always travels in the form of packets of energy. That packets of energy we call it as photons. Okay, now these photons are also the fundamental particles. And they are the part of electromagnetic radiations. Okay, now they carry electromagnetic radiations. Okay, now bosons are the fundamental particles like this. So first we'll go to the list of these fundamental particles. First make a note of this. Atom. Atom is a basic structure. Atom is a basic structure made up of electrons, protons, and neutrons. Electrons, protons, and neutrons. Protons and neutrons are present inside the nucleus. Protons and neutrons are present inside the nucleus. Neutrons are present inside the nucleus. Whereas electrons revolves around the nucleus. Whereas electrons revolves around the nucleus at higher speeds. Revolves around the nucleus at higher speeds. Fundamental particles that exist in nature are responsible for carrying a force and mass. Responsible for carrying a force as well as mass. Force and mass. They are basically categorized into two types. Fermions and bosons. Basically categorized into two types. That is fermions and bosons. Just listen once. So stop writing there. Complete writing fermions and bosons. Okay. So like this, in nature there are two types of fundamental particles. One is fermions. Next one is bosons. Fermions are the mass carriers. They carry the mass. Okay. Mass is nothing but quantity of energy. Okay. Next one is bosons are the force carriers. These bosons are further categorized into two types. Gauge bosons, next one is scalar bosons. Examples of scalar bosons is Higgs bosons. Gauge bosons includes photons, W and Z bosons. Next one is gluons, gravitons. These are the fundamental particle comes under the gauge bosons. Okay, photons is one of the fundamental particles. W and Z bosons are the another fundamental particles. Gluons are the other fundamental particles. Gravitons are the other fundamental particles that comes under the gauge bosons. And coming to this, fermions. Fermions are further categorized into two types: quarks, anti-quarks. Next one is leptons, anti-leptons. Okay, and these quarks are further categorized into six categories like this: up quark, down quark, charm quarks, strange quarks, top and bottom quarks. These are the 6 categories of quarks. And leptons are further categorized into like this: electron neutrinos, mau neutrinos, tau neutrinos. Okay, now like this the electrons has been categorized. That means neutrinos and bosons are the part of elementary particles or not? Fundamental particles of universe or not? Yes. Okay, next series. First shall we write this? First copy this flowchart now. So while writing this fermions, above that, right there, right here itself, these are the mass carriers. Right here, mass carriers, and here it is force carriers. force carriers. Fermions are the mass carriers. Bosons are the force carriers. Next one is fermions includes. Fermions are further categorized into two types. What are those two types of these fermions? Quarks, antiquarks. Quarks, antiquarks. Next one is leptons, antileptons. And bosons are further categorized into two types: gauge bosons, scalar bosons. Gauge bosons and scalar bosons. So what is the example of these scalar bosons? Higgs bosons. Scalar bosons is an Higgs boson particles. And gauge bosons includes photons, W and Z bosons, Next one is gluons and gravitons. Photons, W and Z bosons, gluons, and next one is gravitons. Okay, next one is coming to this leptons and antileptons includes electrons, electron neutrinos, muons, muon neutrinos, tau, tau neutrinos. And next one is quarks. How many varieties of quarks are there? 6 varieties of quarks are there. How many varieties of leptons are there? 6 varieties of leptons are there. Okay, friends. Electrons, electron neutrinos. Next one is muon neutrinos, tau and tau neutrinos. Like this, 6 categories are there. Okay, now quarks are also like that. 6 categories are there. Up quark, down quark, charm quark, strange quark, top and bottom quark. So like this, the fundamental particles have been categorized. And what is the use of these quarks, leptons means? Now we will see this. So is it clear regarding to this flowchart? Is it clear regarding to the flowchart, friends? Which particles are the mass carriers? Fermions. Which particles are the force carriers? Bosons. So four basic fundamental forces are because of which particles? 4 fundamental forces are there now. Okay, now it is because of which particles? Bosons. Okay, now there are 4. Once again, I am repeating. There are 4 fundamental particles in the universe. That 4 fundamental what we call it as forces. That 4 fundamental forces is the result of what means bosons. Okay, now mass. From one particle to other particles, mass will be distributed. You know that energy can't be destroyed, not be created, but it always transforms from one form to the another form. Okay, now, so what is a mass means? Mass is nothing but quantity of energy. This quantity of energy will be shared from one particle to the another particles. Like that, each and every particle will have a mass. Okay, now, hence we call it as a mass carriers means. Got it? Next one is anomalies. So this is the flowchart regarding this. Just listen carefully first, then we can write it. So this up quark and down quarks. These up quark and down quark are produced because of these strings. Okay, now what strings are made up of means we don't know exactly, because this is the proposed model, fundamental hypothesis model that was given by the scientist. Means it was not scientifically proved yet. But what scientists are saying is this is how the electrons, neutrons, protons, and atoms, molecules, matter will be found on the Earth. Okay, now, so this not only on Earth, in every means universe. So strings are responsible for formation of up quark and down quarks. This up quark and down quark is series. This is a proton and this is a neutron. How these protons and neutrons are produced? Protons are produced by 2 up quarks and 1 down quark. And these mass quarks particles are holded by what means gluons. Gluons are the force particle. Now. To hold this mass particle, force is required. Okay, now, so 2 up quarks and 1 down quark results in formation of protons. And these quarks are holded by what means gluons. Next one is if you see the neutrons. How these neutrons are produced? Neutrons are made up of what? 2 down quark, 1 up quark. And it is holded by what means gluons. These protons and neutrons together forms what? Atomic nucleus. So protons and neutrons are present in the nucleus of an atom. Now. We have written it first to that. Okay, now, and this nucleus will enter into the center of the atom, and electron will enter into the atom, and it results in formation of complete structure of the atom. Protons present in the nucleus of an atom consist of positive charge. Electrons consist of negative charge. Because of these two unlike charges, the atomic structure is highly stable in nature. So you may get doubt, so if electrons are revolving in fastly surrounding the nucleus, it should come out of the atom, but it is not coming out of the atoms. Atomic structure is stable in nature. Why it is stable in nature means because electrons will have negative charge, protons will have positive charge. These two unlike charges balances each other. So hence atomic structure is remaining stable in nature. These atoms combine together from molecules. Molecules resulting in formation of matter. Matter results in formation of living organisms. This is how the evolution of life takes place. Formation of substances, different molecules, or anything, how the formation takes place means this is how the formation takes place. This is how fundamental particles, that is force particles and matter particles, are responsible for formation of atoms and molecules. Got it, students? Shall we write this flowchart? Copy this flowchart. Matter and energy. Right? First write one sentence, then we can copy it. Matter and energy will flows from one particle to the another particles. Okay, now, the following proposed model clearly explains the matter and energy flow. Okay, now, so let's make a note now. You can make a note like this. Two strings are responsible for formation of quarks, up quark and down quark. Is it visible? Is it visible? Is it okay now? Not okay. First copy this. Strings are responsible for formation of up quark and down quark. And two up quarks, one down quark results in formation of what? Protons. Two up quark and one down quarks results in formation of protons. This is a proton and this is a neutrons. Two up quarks and one down quarks results in formation of what means? Proton. And what is G means? Gluons. And next one is, after that protons, next one is what? Neutrons. What is neutrons? Consists of two down quarks and one up quark. It is holded by what means? Gluons. Neutrons consists of two down quarks and one up quark. Two down quarks, one up quark, and these are holded by what means? Gluons. And these we call it as neutrons. Protons and neutrons together forms what means? Atomic nucleus. And next one is done. So I'm asking about protons and neutrons, done. Okay, na? So that's what. And these protons and neutrons together forms what means? Atomic nucleus, and with electrons, atomic structure will be formed. Is it clear now how neutrons, electrons, means so protons are produced? Neutrons and protons are made up of what means? Quarks and gluons. But what about the electrons? Electrons are made up of, I will tell you that, leptons. Okay, na? Strings. Strings are much more basic particles which is responsible for formation of quarks. What exactly it is made up of, we don't know that. But scientists have given that strings are responsible for formation of quarks. Done, students? Completed? So write under that. Yes. Right, like this. Protons are made up of two up quarks and one down quark. Two up quarks and one down quark. And one down quark. And next one is neutrons are made up of two down quarks and one up quark. Two down quarks and one up quark. Okay, the next one is electrons are made up of leptons. Electrons are made up of leptons. Leptons. We have written leptons now. Okay, na? Electrons are made up of leptons. Okay, the next one is protons and neutrons in the nucleus of an atom. Protons and neutrons in the nucleus of an atom together will have positive charge. Together will have positive charge. And electrons that revolves, and electrons that are revolving around the nucleus, electrons that are revolving around the nucleus will have negative charge. Will have a negative charge. Even though electrons revolves around the nucleus, electrons revolves around the nucleus at higher speeds, it doesn't comes out of the atom. Due to this unlike charges, which attracts together. Hence atom structure is stable. Hence atom structure is stable. Stable. S-T-A-B-L-E. Stable. Okay, na? Done? Clear? Is it clear now? Okay, na? That is what. So this is what the fundamental particles, and what the fundamental particles, two types of fundamental particles, fermions and bosons, and what is the use of this fundamental particles. And next one is the four basic fundamental forces. The four basic fundamental forces that exist in nature. Is a result of bosons. Next one is Higgs boson. Generally, Higgs boson, recently it was discovered, students, and Higgs boson is considered as a God particle. So why it is considered as a God particle, and through what experiment they have discovered this Higgs boson particle, students? Which experiment has led to the discovery of this Higgs boson particle. Have you heard about this LHC experiment? What is this? LHC means Large Hadron Collider. So this is an laboratory which is in European Union, and what they have done in the laboratory is regarding to this Higgs bosons. So this is what the LHC. What is LHC means? Large Hadron Collider. Okay now. So this LHC is 27-kilometer long tunnel. Okay now. It has 27 kilometers long tunnel like this, and in this tunnel it has a high powered electromagnets. And these high powered electromagnets, inside these high powered electromagnets, what we have done is we made two protons to travel in opposite directions at a light speed. Okay now. Two protons were allowed to travel at a light speed. Okay now. So when they are allowed to travel at a light speed in this tunnel, these two protons will collide at a particular place. Because of this collision, what happens means they results in formation of Higgs bosons. Like this Higgs boson particle was discovered in 2012, and it was referred to as a God particle. Why it was referred as a God particle means because that is the particle which is transferring the mass from one particle to the another particle. That scientists consider it as a basic particle. You know, with LHC experiment, LHC laboratory, they have discovered the existence of what we call it as a bosons, means Higgs boson. What it means? Peter Higgs is the scientist who discovered this boson particle, and why he named it as a Higgs boson means he is a student of Satyendranath Bose of India, and giving honor to the guru, he named that God particles as a Higgs bosons. Got clarity, students? So that is what the LHC experiment is. And now, European Union, they are going to increase the what we call it as a range of tunnel from 27 kilometers to they want to extend up to the 60 kilometers for further research purpose. Okay, now that is what Higgs bosons means. And next one is, what are these neutrinos? Neutrinos in our universe, largest number of fundamental particles is what means photons. Okay, now photons are the largest number of fundamental elementary particles. Okay, after photons, second largest number of fundamental elementary particles are neutrinos. What is the source of these neutrinos? Sun and stars are the source of neutrinos. Okay, now, and neutrinos, other than the sun and stars, neutrinos can be produced from the nuclear reactors. On the earth, neutrinos can be produced from the nuclear reactors. Does this neutrinos has a charge means? No. They are chargeless. When any substance, when it is not having any charge, so what that basic character it has means it never interacts with other particles. When they are never interacting with other particles, it is very hard to detect. Okay, that is one thing. Do neutrinos has a mass means? Yes, neutrinos has a mass. Earlier scientists has thought that neutrinos are not having a mass, but later scientists have discovered that neutrinos are having a mass. Okay, now neutrinos discovery was also done. For both the discoveries of Higgs boson and neutrinos, they got Nobel Prize. Neutrinos are referred as ghost particles. Why it is a ghost particles means these neutrinos throughout the universe without any obstacle they travel like a ghost, like how the ghost travels now. So crores of neutrinos will pass through us every second. Crores of neutrinos will pass through us, but they doesn't interact because they are chargeless. And what government of India is doing? What are we establishing any project regarding to this neutrinos means? Yes, we want to do research on these neutrinos for further development of technologies. Hence, neutrino laboratory, one of the world's biggest neutrino laboratory, was announced in where? Tamil Nadu. So earlier, before this Tamil Nadu project, that we have already neutrino laboratory. It was established in KGF. KGF means what? KGF 1, KGF 2. You know that? KGF means Kolar goldfield mines. When Kolar goldfield mines are viable in nature, okay, there it was a neutrino laboratory was there. Later, when Kolar goldfield mines were shut down, this neutrino laboratory was also shut down. And now we started establishing one of the world's largest neutrino laboratory in Tamil Nadu students. So it is continuously in the news. And neutrinos, what these neutrinos means? These neutrinos are the second largest fundamental particles after photons. Okay, and we are trying to explore the properties of neutrinos. We are trying to explore the properties of Higgs boson particle. We have discovered the existence of Higgs boson particle, but we didn't study the properties of Higgs boson particle. Why? Because lifespan of Higgs boson is in seconds. Hence, we are unable to study it. We are focusing on to study the properties of these Higgs bosons. Neutrinos, as I told you that neutrinos are very hard to detect. We have discovered the existence of neutrinos, but the properties of neutrinos are yet to be known. Okay, say for example, if you know the properties of neutrinos, so I told you that they are chargeless. Okay, and they pass through any object without any obstacle. Can we develop a new imaging technologies, alternative to X-ray technologies, CT scan like that, which includes radiational effects? When we use these neutrinos, no radiational effects will be there, nothing will be there. Okay, can we develop a new imaging technologies which are of no radiation? Yes. When they are traveling across the universe, can we know that what is there in our universe? Okay, imaging of universe is possible. Deeper insights of the universe can be known. So all we need is some particles, some energy which is traveling across the universe. We need it. Why? Because whatever the technology we have, with existing technologies, we are unable to generate energy or waves which travels across the universe. Okay, hence we want to use such kind of what we call it as a neutrinos or gravitational waves, or next one is boson particles for developing of new technologies. Hence we want to know the properties of these neutrinos. These neutrinos will travel without any obstacles now. They travel into the deeper layers of Earth crust or not? Yes, we can know with the help of this. We can know that what is there exactly in the deeper layers of the Earth crust. We can know the interior layers of Earth crust. We can map the interior layers of Earth crust exactly. Okay, now, and probing of early universe is possible. Probing of early universe means during the initial stages of universe, what is there? How the Big Bang has been happened. So what is the result of this Big Bangs? Some insights, in-depth insights of early universe can be known by studying the properties of what we call as neutrinos. Okay, now, and if you study the properties of neutrinos, the major source of neutrinos is sun and stars. Now, okay, now, we can know what is happening in sun. So if you see outer layer of the sun is too hot when compared to the inner layers, why it is? We can get this kind of information regarding to the sun and stars. Does all the stars are similar in nature? Is any different kind of stars are there other than our universe? We can know it. Okay, now, such kind of information can be collected from the universe when these neutrinos are traveling across the universe. Okay, now, hence neutrinos are referred as what? Ghost particles. And next one is Higgs boson particle is referred as what? God particle. Shall we write this? Okay, make a note of this Higgs boson. Higgs boson is sometimes referred as God particles. Sometimes referred as God particles. because these particles will share mass with other particles. Okay, now next one is discovery of this Higgs boson particle. Discovery of this Higgs boson particle was done with LHC experiment. LHC, Large Hadron Collider or Collider. Large Hadron Collider. LHC. It is the world's largest and most powerful accelerator. Next one is, in this experiment, two protons are allowed to travel in opposite direction. At a particular point, these two protons collide at a light speed. Resulting in formation of Higgs bosons. Resulting in formation of Higgs bosons. Okay, that is how the Higgs boson discovery was done. Next one is unknowns. Neutrinos. Take it, neutrinos. After photons, neutrinos are the second most abundant particles in the universe. Second most fundamental particles in the universe. Sources of neutrinos are. First one, sun and stars. Next one is, if it is on the earth it is nuclear reactors. Nuclear reactors. Okay, next one. Okay, next one is another point regarding this is neutrinos features. Take getting features of neutrinos. Features of neutrinos. First one is chargeless. Next one is mass particles. Neutrinos are of chargeless and mass particles. Right like this. Right under that. Due to lack of charge, neutrinos doesn't interact with any other substances. Hence they are hard to detect. Okay, next one is, due to the existence of mass, neutrinos are further categorized into following types. That is electron neutrinos. Next one is muon neutrinos, tau neutrinos, and sterile neutrinos. Okay, now next one is. So these are the different types of neutrinos, what they exist. Next one is, neutrinos are referred as ghost particles. Because without any obstacle, it travels across the universe. Okay, and it has following applications. First one is probing of early universe. Next one is, second point, interior layers of earth can be studied. Next one is studying of sun and star properties. Developing new imaging technologies developing new imaging technologies like X-ray and CT scan, like X-ray and CT scans, X-ray and CT scan. Got students? That is what regarding this. So that is what regarding the neutrinos. Okay, this is how we are exploring the space. For what purpose we are exploring the space? For carbon dioxide and water we are exploring the space. We have sent this Chandrayaan-3 mission to the moon. For what purpose? For exploring the water in south polar region of the moon. Okay, next one is we are searching for alien life. We are searching for Earth-like planets. We call it as a habitable zones. Okay, yes, Goldilocks zones. Okay, next one is other than this, we have discovered the gravitational waves. We have discovered the neutrinos. We have discovered the Higgs boson particles. Okay, and next one is this is black holes. We have discovered the existence of black holes, and we are studying regarding to the wormholes. So that is how we are exploring the space, outer space. Okay, now, what are the tools that are necessary for exploration of outer space means? I have written the list of the tools. Okay, now, space-based telescopes are required, ground-based telescopes are required, rockets are required, space missions are required. Okay, like this, international space stations are required. Next one is deep space networks are required. So these are the tools which are required for the exploration of space. And how we are utilizing the space. Next comes the topic is utilization of space. In what way we are utilizing the space? How we are utilizing the space? What are the tools that we are using in utilization of space? So make a note of this. Utilization of space. Space utilization. Utilization of space is for what purpose means? Communication purpose. Communication purpose. Remote sensing purpose. Remote sensing purpose. The next one is navigation purpose. Navigation purpose. And what are the tools that are required for this? Rockets are required. Next one is satellites. Satellites are required for utilization of space. Next one is national database centers. National database centers are required. Communications. Every communication we are performing with the help of satellites now. So radio communication, mobile communication, satellite communications. And next one is telecommunications. All these communications is because of this satellites, communication satellites from the space only. So this is how we are utilizing the space. Okay, friends. So utilization of space is like this. So when we started utilizing the space, so in India when we have launched this, so what is the genesis? How this space utilization has been started? Take heading genesis of Indian space program. Genesis of Indian space program. So this regarding to this how ISRO has been started and how we have started this space utilization. In 1960s we have started this space utilization friends. In 1960s what happens means, so with the help of SYNCOM-3 satellite, that is the US satellite, okay now, and with that satellite they have live telecasted this Tokyo Olympic Games, you know, and with it, to that event from India, Vikram Sarabhai has attended this, okay now, there he came to know that, there he was enlightened, okay now, and he came to know the potentiality of the space utilization, and he came to know the potentiality of satellites in development of a particular country. Immediately after this in India we have launched this, what means we have established this. So this Indian National Committee for Space Research in 1962 it was established. So later by 1969 it was renamed as what means ISRO students. And ISRO was first started in a small church in Kerala. There is a fishing village in Kerala that we call it as an Tumba. Okay, now, in that Tumba village, the first ISRO's activities have been started in this church. We call it as a Mary Magdalena Church, and it is popularly known as Mecca of Indian Space Program. Okay, now here we started these space activities, and slowly we started developing this rocket system. Slowly we started developing our satellite systems like that. Like that, ISRO's activities have been started. That is what the genesis of ISRO means. Later on, once after developing these rocket systems, once after developing these satellite systems, India's own satellite and rocket systems, then we started for what we call it as a social sector programs like that with the help of satellites. Okay, now, so that is how the ISRO genesis has been happened, students. Okay, now, so this I will share you the PDF. Okay, you can go to that. I will give you the major points in the notes. Okay, now, make a note like this. In 1960s, Tokyo Olympic Games was live telecasted. Tokyo Olympic Games was live telecasted by SYNCOM-3 satellites. SYNCOM-3 satellite of USA. SYNCOM-3 satellite of USA. To this event, Vikram Sarabhai has attended from India. To this event, Vikram Sarabhai has attended from India. This event has led to the establishment of Indian National Committee for Space Research. Establishment of Indian National Committee for Space Research in 1962. Space research in 1962. And in 1969, it was further renamed as ISRO. Indian Space Research Organization. So what happens means after this in 1969, in 1970s, first we started what we call it as launching the satellites with the help of other countries. Later on, we started developing, in 1970s, we started developing our own rocket systems and satellite systems. By the time of 1980s, we have developed our own rocket system. Okay, so this is Vikram Sarabhai and Abdul Kalam. Like this, we have started our own rocket first, that we call it as SLV rocket. We have developed our own rocket in 1970s. By the time of 1980s, we have developed our own satellites. Okay, and by the time of 1990s, we developed a PSLV, and we started launching our satellites on our own into the orbits. And by the time of 2000, we started providing services to other countries. In 21st century, India is one of the top 5 nations in the world regarding to the space program. Now we have a capability of launching the space missions. We have developed different versions of rocket. We have what we call it as space missions. India has launched the space missions into the orbits, the cheapest space missions into the orbits. Like this, our Indian space technological development has been happened. Okay, so now India is providing space related services to many countries in the world. Okay, that is how the genesis of ISRO has been taking place. What is, students? That is how we are utilizing the space, and next one is exploration of space is happening, students. So this is the thing, basic information regarding this. So first, what I will do here is I will give you information regarding the rocket systems of India. So based on what principle these rocket systems have been developed, and why always rocket launching stations are established nearer to the equator. Why India is launching these rockets from east coast of India? Why not from the west coast? Okay, and what are the different versions of rocket that we have in India? Okay, students. And regarding to this, how many rocket launching stations are there in India? How many rocket launching stations are there? How many rocket launching stations are there in India? Only 2, 3, 4. If it is 2, what are those? Sriharikota, Vikram Sarabhai. Okay, now next, another one. Okay, okay, I will tell you that. Okay. I will tell you that. Don't strain your brains. I will give you information regarding this. So rockets, basically, rockets are launch vehicles. Works based on the principles of what means Newton's laws. Okay, Newton's laws are applicable when a particular object is in motion. So first law of Newton's is what? An object is said to be at rest or in constant motion until external force is applied. Okay, that is what law of inertia means. And second formula is F is equal to ma. Force is equal to mass into acceleration. And next one is third law. You know that for every reaction there will be an equal and opposite reaction. Okay, now that is what 3 laws. All the 3 laws are applicable in the rockets as well as in missiles. Okay, now, so it works based on the Newton's laws. Got clarity, students? And next one is, so what are the different rocket systems? Like what are the versions of the rocket systems? How it has been developed? What are the characteristic features of the rocket? We'll discuss that. Take heading: Rocket Systems of India. So okay, India rocket launch station. There are total 3 rocket launch stations are there. 3 rocket launch stations. One is Toothukudi rocket launch station. It is Terrals is in Kerala. Next one, it is in Andhra Pradesh. It is in Tamil Nadu. Terrals means Tumba Equatorial Rocket Launch Station. Next one is SDSC Shah means Satish Dhawan Space Center. Next one is Sriharikota High Altitude Range. Sriharikota High Altitude Range. India's first rocket launch station. And we are currently using this India's first rocket launching station for Rohini and sounding rockets. We are using it for launching Rohini as well as sounding rockets, popularly known as Spaceport of India. Used for all the commercial launches. Next one is Toothukudi. Small satellite launch vehicles. SLV. Okay, now used for launching small satellite launch vehicles. That is Toothpuri rocket launching station, which was recently established. Okay, now and Spaceport of India. All the commercial launches will be done from where means SHAR, SDSG, SHAR. And next one is India's first rocket launching station is Tumba Equatorial Rocket Launching Station. It is also known as Vikram Sarabhai Rocket Launching Station. So Tumba is also known as Vikram Sarabhai Rocket Launching Station. Make a note of that point also. Tumba is also known as Vikram Sarabhai Rocket Launching Station. Got clarity, friends? These are the 3 rocket launch stations. So for sounding as well as Rohini rockets, we are using Tumba. What is Rohini and sounding rockets means? I will explain you in next topic. Here you have to remember that for launching of Rohini as well as sounding rockets, we are using Tumba. And for all commercial launches as well as any rockets can be launched from SHAR. Rohini rockets also can be launched from SHAR. Every commercial launch vehicle is from the SHAR only. Hence we call it as a spaceport of India, friends. Okay, the next one is Toothpuri is especially designed for what means small satellite launch vehicles. These are the 3 rocket launching stations that are present in India. So next one is another important point is any country in the world will establish this rocket launching station near to the equator. Any country in the world will establish these rocket launching stations near to the equator. Why they establish near to the equator? Why they establish near to the equator? So because gravitational force is minimum at equator, maximum at poles, 0 at the center. Okay, it is minimum at equator, maximum at poles, 0 at the center. Hence, when we establish these rocket launch stations nearer to the equator, what happens means gravitational pull will be very less. Because of this less gravitational pull, we can launch the rocket with a cheaper cost. Fuel consumption cost will be reduced. Hence, rocket launching stations are always established near to the equator only. In India, what we have done, India is present nearer to the equator or far away from the equator? Nearer to the equator. Above the equator or below the equator? Above the equator. So when we are above the equator, when India is present above the equator, friends, here, so we are launching these rockets from east coast. Why we are launching the rockets from east coast? Something you said. Okay, I'll make it clear. So first one is when we are launching the rockets, when there is a technical failure, we can bring down the rockets into the Bay of Bengal because area of Bay of Bengal is huge compared to the Arabian Sea. That is one thing. And next one is just let me explain. Okay, rotation of Earth is from west to east. Because of this rotation of Earth from west to east, so what happens means already we have an added benefit of that is India is nearer to the equator, gravitational pull is less, and it is followed by Earth's rotational speed. So what happens means when we launch from east side, so it will give further push to the rocket. Hence, rocket launching cost become further cheaper. That is another benefit. And one more benefit is also there. When we are launching the satellites from the east coast, especially communication satellites, to place it in the geostationary orbits, it will be easy. Otherwise, it will be difficult to place satellites into the geostationary orbit. So these are the 3 benefits what we get by launching the rockets from the east coast. But don't take it for granted that rockets cannot be launched from west coast. Rockets can be launched from west coast. So hardly launching time of rockets means satellites into the orbit with the help of rocket is 5 to 10 minutes. If any technical failure is there, what happens means it will fall into the land. It may result in disastrous effects. Hence, we have avoided launching from the west coast. So we can launch the rockets from west coast. We can launch the rockets from east coast. But for our convenience, we selected the east coast. Got it, friends? That is what regarding this rocket launching stations, why they are established. Shall we write regarding this? First, start writing like this: rockets are launch vehicles. Rockets are launch vehicles. Works based on the principles of Newton's laws. Principles of Newton's laws. All the 3 Newton's laws are applicable. All the 3 Newton's laws are applicable. Okay, next one is across the world, rocket launching stations are established near to the equator. Rocket launching stations are established near to the equator. Because of less gravitational pull. Hence, launching cost becomes cheaper. Take it in, do you know? So wherever do you know is there, you don't know anything regarding to that. Because of that, we are writing that. Gravitational pull is minimum at equator. Maximum at poles. 0 at the center of the earth. Okay, next one is come out of this, do you know, and write. Okay, India is a subtropical country. That means it lies above the equator. Hence, natural benefit already exists in launching of rockets. Natural benefits already exist in launching of rockets. Along with this, to get added benefit, India started launching rockets. India started launching rockets from East Coast. Started launching rockets from East Coast. Okay, now benefits are, the benefits are, first one is technical failure of rocket. Technical failure of rocket can be channelized into, in technical failure of rocket can be channelized into waters. Can be channelized into the waters. In technical failures of rocket can be channelized into the waters. Right in the bracket, Bay of Bengal. Okay, the next one is Earth rotates from west to east. Earth rotates from west to east. Hence, launching of rockets from east coast. Hence, launching of rockets from east coast becomes much more cheaper. Becomes much more cheaper. Becomes much more cheaper. Okay, now this is due to the initial push of rocket. Okay, now the next one is to place satellites exactly into the geostationary orbits. To place satellites exactly into the geostationary orbits. To place satellites exactly into the geostationary orbits, it is useful. Geostationary orbits, it is useful. So that is the reason why we are launching rockets from the east coast. Launching of satellites into the orbits in India is much more cheaper compared to the other nations. Okay, now this is the added benefit regarding this India students. Got clarity on this? Okay, now so what are the different versions of Indian rocket systems? So I will make a list of all this. We have seen the rocket launching stations and on what basis this rocket works and what are the different versions of Indian rocket systems. Okay, now make a note like this. Copy this. Okay, now next one is historical rockets, operational rockets, future rockets. Historical rockets includes SLV, ASLV, PSLV, GSLV, GSLV Mk3, GSLV Mk2, SSLV. Operational rockets. Future rocket systems includes historical rockets, operational rockets, future rockets. Historical rockets includes what means SLV, ASLV. ASLV means augmented satellite launch vehicle. PSLV means polar satellite launch vehicle. GSLV means geo stationary or geosynchronous? Geosynchronous. Geosynchronous satellite launch vehicle. Okay, now historical rockets, operational rockets, next one is future rockets. Operational rockets. And next one is future rockets of India. RLV means reusable launch vehicles. RLV means reusable launch vehicles. Reusable launch vehicles. HRLV means human rated launch vehicles. Human rated launch vehicles. Got it, friends? Reusable launch vehicle. Next one is human rated launch vehicles. Got it? SSLV means small satellite launch vehicles. Just I'll explain. Just I'm making you familiar with what are the different types of versions of rockets. Okay, is it clear now? Okay, next one is first we'll start with PSLV rocket systems. Take it in PSLV. So for what purpose we have designed this PSLV rockets? Means for launching of remote sensing satellites into the lower Earth orbits. Take it in PSLV rocket. I will give you specifications regarding to this PSLV rocket ones. What are the different specifications regarding to this PSLV rocket systems? PSLV means polar satellite launch vehicle. And this PSLV rocket systems. So how many stages are there in PSLV systems? Means there are 4 stages. 4 stages in PSLV rockets. So this is the place where satellites will be placed. Okay, now this we call it as an payload of rocket. Payload of rocket. So where satellites are placed. This is the payload of rocket where satellites are placed. You know, next one is, this is a stage 1, stage 2, stage 3, and 4th stage. Stage 4. So like this, how many stages are there in PSLV rocket? 4 stages are there. In the first stage, what is the fuel that is used in the first stage? Means solid fuel propellant is used. In the first stage, solid fuel propellant is used. In second stage, liquid fuel propellant is used. Third stage, again solid fuel propellant. And here it is a liquid fuel propellant. So like this, in alternatively, solid and liquid fuels are used in 4 stages. You know. So at the bottom of the rocket, at the base of the rocket, we have, at base of the rocket we have strap-on motors as well as booster straps. We have strap-on motors or booster straps. Booster straps. So what is the use of the strap-on motors or booster straps? During the initial takeoff of rocket, it will give thrust. Okay, now provides a thrust. Provides thrust during the initial takeoff. During the initial takeoff. And in the second stage of PSLV rocket, Vikas engine is used. Vikas engine is used in the second stage of PSLV rocket. Okay. Only in second stage, Vikas engine was used. For the first time, we developed this Vikas engine. It was introduced into the PSLV rockets. You know. Based on this number of the strap-on motors. Based on number of strap-on motors. Based on the number of strap-on motors of rocket, PSLV are categorized into following types. PSLV CA, PSLV XL, PSLV QL, PSLV DL. Based on the number of strap-on motors. CA means core alone version. Here, no strap-on motors. There won't be any strap-on motors in CA. Okay, and next one is XL has 6 strap-on motors, QL has 4 strap-on motors, DL has 2 strap-on motors. DL version of PSLV has 2 strap-on motors. Okay, QL version of PSLV has 4 strap-on motors. XL version of PSLV has 6 strap-on motors. What is the use of the strap-on motors? While during the takeoff of rocket, it gives thrust. Okay, because rocket is very heavy in nature now. Because of it, we need extra fuel during the takeoff. So that extra thrust means nothing but force. Force will be provided by this strap-on motors or booster straps. So based on the number of strap-on motors and booster straps, PSLV is categorized into 4 different versions. In the CA, this only core will be there. In core alone version means only core will be there. Strap-on motors doesn't exist. Strap-on motors are not present. Only this core will be there. Okay, that hence we call it as a core alone version. No strap-on motors. PSLV XL, how many? 6. PSLV QL, 4. There we have written what version of rocket? PSLV QL. And DL means how many strap-on motors? 2 strap-on motors. In which stage of PSLV rocket Vikas engine is used? Second stage. How many stages are there in PSLV? 4 stages. In all these 4 stages, solid and liquid fuels are used in alternative manner. Where rockets are placed? Where satellites are placed? So at the top of the rocket, satellites are placed. That we call it as a payload of rocket. Payload means what? Means how much weight a particular rocket is able to carry. That we call it as a payload. Got clarity, students? Okay, now shall we take a break? Take a break. After the break, we'll continue. What are the doubts you have? I will take after the class. Okay, now. And so this regarding to this PSLV, for what purpose we have designed this PSLV? These are the specifications regarding to PSLV, what we have written here, okay, now, what we have copied. And what is the specification, for what purpose PSLV has developed, and what is the payload carrying capacity of PSLV? So with this PSLV, how many launches we have done already so far? Out of it, how many success, how many are failure? Why PSLV is considered as workhorse of ISRO? Okay, now, like this. And here you may get doubt that, sir, why this liquid and solid fuels are used in an alternative manner? Okay, now, so why means it depends. Use of fuels always depends upon the payload carrying capacity of the rocket. I will explain you in clear-cut manner in case of fuel topics. Okay, now, so everything I will explain you regarding this. First, I am familiarizing with what actually the types of rockets, what are the specifications of the rockets, what are the types of fuels used in the rockets, what is the payload carrying capacity of the rockets. After this information, I will take the fuel topic. There I will explain you on what basis the fuel will be used in each and every stages. Okay, students, that is one thing you should remember. Next one is another important point regarding this is PSLV rockets are especially designed for launching remote sensing satellites into the lower Earth orbits or polar orbits and sun synchronous orbits. And one more thing is PSLV is known as workhorse of ISRO. Out of total launches, only 2 failures are there. Means PSLV's track is highly success. Only 2 failures are there, and so hence it is considered as workhorse of ISRO, most reliable vehicle in the world. And next one is with PSLV rocket, we can launch multiple satellites into single orbit. We can launch multiple satellites into multiple orbits. Multiple satellites can be launched into the multiple orbits. Multiple satellites can be launched into the single orbit. Are getting my point, friends? That is what. Okay, and this PSLV rocket, regarding to this PSLV, this 4th stage, recently ISRO has tested twice. This 4th stage itself will act like a satellite. Okay, now, that means to overcome the space debris, to make rockets more efficient. Okay, after launching the satellites, the PS4 stage, okay, that stage itself will act like a satellite for a certain period of time. Okay, that we call it as an orbital module. We have tested in PSLV C45 rocket. We have tested in PSLV C53 rocket. Okay, these are the important points regarding this PSLV students. Understood regarding to the versions of the rocket? Any doubt regarding to this? Okay, right. Any doubt means you can raise the doubts. I will answer it. Otherwise, we will write the basic information first. Okay, make a note of this. PSLV was initially designed. PSLV was initially designed for launching of remote sensing satellites. For launching of remote sensing satellites into the lower Earth orbits, or polar orbits, and sun synchronous orbits. Sun synchronous. Okay, is it okay now? Okay, now that is what. Next one is but currently PSLV is used for multi-purpose manner. PSLV is used for multi-purpose. Okay, next one is. So especially initially it was designed for remote sensing. Now we are launching for space missions. Chandrayaan-3 space mission was launched into the lower Earth orbit. Okay, now, earlier we used it for Chandrayaan mission only. Mangalyaan mission we have used it. Like this for space missions launching also PSLV rocket we are using it. Okay, now, we are trying to launch communication satellites. Already we have tested once, and in future it will be launched. So it has become now multi-purpose. But initially it was designed for launching remote sensing satellites. So whatever this lower Earth orbits, polar orbits, and sun synchronous orbits, after these rocket systems, before starting the satellites, I will take the orbits and its types. Okay, now, first you have to remember this. I am making you familiarized with what are the different types of orbits we have. Got it, students? Okay, now, so that is what. Next one is another point is PSLV is known as workhorse of ISRO. Workhorse of ISRO / most reliable vehicle in the world. Okay, because so far it has launched for 59 times. How many times it has launched? How many launches have completed? 59 launches have been completed. Out of 59, how many successful? 57 are successful. Okay, make a note of it. So far it has launched for 59 times. Out of it, 2 are failure. Okay, next one is next point. PSLV rocket has a capability. To launch multiple satellites into single orbit. Multiple satellites into single orbit. As well as multiple satellites into multiple orbits. Okay, next one is for the first time in PSLV C45, and PSLV C53. 4th stage of rocket is used as a satellite. After launching all the payloads. That is known as PSLV orbital experimental module. POEM. POEM. PSLV. P means PSLV. O means orbital. E means experimental. M means module. This is what about this PSLV rocket students. And what is the payload carrying capacity of PSLV rocket? I will give you information regarding this PSLV payload carrying capacity. It is a short time now. Just we'll see this What is this PSLV C45? How it is an experimental module? We'll see that. Just a minute. Sound is not there. Sami sir. Yes, sir. So this is a PSLV C45 rocket students. So here we need to check how many strap-on motors are there. What are the different types of PSLV rockets, and how the fourth stage is used as an orbital module, and how this rocket will launch multiple satellites into multiple orbits. We have to check all those things, students. Okay? So in this video, you get all this information. Just a minute. So how many strap-on motors are there here? 4. It is a QL version or not? Yes. Like this, we have core L1 version. Next one is XL.
Strap-on motors, weighing 436. In its 47th mission, PSLV C45, the polar satellite launch vehicle of ISRO, is set to launch 29 satellites. In this flight, the vehicle will place the satellites in 2 different orbits. For the first time, the QL variant of PSLV with 4 strap-on motors is being flown in this flight. In all its earlier flights, PSLV had flown with 2, 6, or without any strap-on motors. Weighing 436 kilograms, EMI-SAT of India is the primary satellite to be launched in this mission. Along with this satellite, PSLV C45 will launch 28 customer satellites.
So that means India is providing services to
24 of these customer satellites are from the USA, which include 20 Flock Earth observation satellites and 4 Lemur satellites with Bessel automatic identification system. The other 4 satellites are from Lithuania, Spain, and Switzerland. This flight will also utilize the 4th stage of PSLV as an orbital platform for carrying out space-borne experiments. For this, the stage is equipped with 3 Indian payloads. Automatic Packet Repeating System, APRS from AMSAT India. Automatic Identification System, AIS of ISRO. And Advanced Retarding Potential Analyzer for Ionospheric Studies, ARIES, from Indian Institute of Space Science and Technology. APRS is a digital repeater for amateur radio applications. It will assist amateur radio operators in tracking and monitoring position data. AIS is meant for automatic identification of ships. It will function by capturing messages transmitted from ships and relaying them to ground stations. ARIES is a plasma and electrostatic instrument, which is meant for structural and compositional studies of ionosphere. In this mission, PSLV will first inject EMI-SAT into an orbit of 749 kilometers. Subsequently, PS4 will come down to 504 kilometers orbit.
So after firing satellites will be launched in different orbits.
And will release 28 foreign satellites.
So like that, it will launch into the different orbits.
Eventually, the stage will achieve a 485 kilometers orbit.
So when they want to change the orbit from higher to lower, see that they're igniting
Carry
engines.
out space-borne
With ignition of
experiments
engines, they will
using
change the
its 3
orbit.
payloads. For the first time, PSLV 4th stage will also have solar panel for generating electrical power in orbit. The availability of PS4 as a test platform will provide an opportunity to study Earth's ionosphere in real time, which is expected to help in developing accurate ionospheric models, which in turn will be helpful in improving accuracy of satellite navigation signals. These models will also help in many other applications. PSLV C45 flight is now ready to begin its journey from the second launch pad of Satish Dhawan Space Center, Shar, Sriharikota, the spaceport of India.
Okay, now every point is there in the notes. Okay, now so that is what regarding to this PSLV systems, PSLV rocket systems. Got clarity how this multiple satellite will be launched into the multiple orbits. Okay, now next one is 4th stage of PSLV is used as a will be used as a satellites. Experimentally, it was first done in the PSLV C45. Okay, now so that is what complete information regarding to this PSLV. Next one is GSLV. GSLV MK2. Mark 2 means nothing but, so that is a code given to that particular vehicle. Mark 2. Okay, no, nothing is there other than that. GSLV means what type of rocket? GSLV, what is the full form of GSLV? Yes, don't say that geostationary. Yes, that's what. Only use geosynchronous. Why means I will explain it. Okay, now, so everywhere when you write this GSLV MK2 or GSLV MK3, remember that. So geosynchronous satellite launch vehicles. Okay, now. So how many stages are there means? 3 stages. So this is a stage 1, stage 2, and stage 3. This is the payload carrying capacity of rocket students. Next one is, what is the payload carrying capacity of GSLV means? If it is GTO orbit, geo transfer orbit, GTO means geo transfer orbit, payload carrying capacity is 2250 kgs. If it is lower Earth orbit, then how many kgs it can carry means 6000 kgs. This is what the payload carrying capacity of GSLV students. strap-on motors or booster straps. There will be 4 strap-on motors. Next one is in first stage. What is the fuel that is used in the stage 1? Solid fuel propellant. Solid fuel propellant is used in first stage. Liquid fuel propellant is used in second stage, and in third stage, gaseous fuels are used. And here it is, Vikas engine is used in second stage, and in third stage, cryogenic engine is used. CE 7.5 kilonewtons capacity of engine is used. How many strap-on motors total? 4 strap-on motors. In each and every strap-on motor, one Vikas engine is used. In each and every strap-on motors, one Vikas engine is used. So Vikas engine is used in second stage as well as in strap-on motors. GTO, LEO are the orbits. GTO means geo transfer orbits. What is the payload carrying capacity of GSLV in GTO orbit? 2250 kg. What is the payload carrying capacity of GSLV in low Earth orbits? 6000 kg. That much weight that particular rocket can carry. What is the meaning of CE? Cryogenic engine 7.5 kilonewtons. That means that much of thrust it can produce. CE means cryogenic engine 7.5 kilonewtons. That much of thrust capacity engine that was it was introduced in only upper stage, not in other stages. Why only in upper stages? I will tell you that. So I told you that initially I am making you familiar with all the specifications of rocket systems. Once it has been done, I will give you the interlinking. First you have to understand this, then only you can understand the remaining things. Okay, why solids are used only in the first stage? Why liquids are used only in the second stage? Like that. Okay, this is what GSLV rockets wants. And GSLV rocket, so regarding to this GSLV rocket, here we have 3 stages. GSLV rockets are initially designed for launching communication satellites into the geosynchronous, geostationary, and geotransfer orbits. But now we are using it for multi-purpose manner. Okay, make a note of this. Got clarity on this total? Okay, right like this. Initially GSLV rockets are designed for launching of communication satellites into geosynchronous, geostationary, and geotransfer orbits. But now these are used for multi-purpose. So far GSLV rocket was launched for 15 times. It was launched for 15 times. Out of it, 4 failures. Are there. Okay, now. In GSLV rocket, Vikas engine is used in second stage. As well as in 4 strap-on motors. Okay, now, total 5 Vikas engines. Right in the bracket, total 5 Vikas engines. So that is what GSLV Mk2 specifications. Okay, next one is GSLV Mk3. Any doubt up to this? PSLV and GSLV? PSLV payload capacity I didn't give, no? So I will give you. First we will complete this GSLV Mk3 and I will give you the payload capacity of PSLV also. Okay, so take heading GSLV Mk3. Mk means what? Mark. Mk3. Here also 3 stages will be there. Here it is. Yes, yes, I know that. I am consciously writing that. Okay, now this is a strap-on motors. This is also a strap-on motor. Next one is, in this strap-on motors, we use S200 solid boosters. S200 solid boosters here also. And in this other stage, we have used liquid stage, core stage. This is a liquid stage. And here it is gaseous stage. Here cryogenic engine is used. Here cryogenic engine, the capacity of cryogenic engine is CE 20 kilonewtons. Capacity of cryogenic engine is CE 20 kilonewtons. Here we have used 2 Vikas engines. And satellites are placed in this room. Payload is, what is the payload of GSLV Mk2? If it is a GTO orbit, 4000 kg. If it is lower Earth orbits, it is 8000 kg. So that is what the payload carrying capacity of GSLV Mk3. So here also 3 stages, no doubt in that. So this strap-on motors were considered as a first stage, this liquid engine stage was considered as a second, and this is considered as a third stage. Like this, 3 stages are there. Number of stages in GSLV Mk3 is also 3. And but what is the difference between GSLV Mk2 and GSLV Mk3 means? So first it is in that GSLV Mk2 CE 7.5 engine is used, but here we used CE 20 kilonewtons. That means capacity of the engine has been enhanced now. Due to enhancement of the capacity of engine, payload carrying capacity of GSLV Mk3 also increased. Hence GSLV is popularly known as Bahubali rocket of India, because it is able to carry heavier payload stones. In strap-on motors we used liquid fuel. Okay, no? In strap-on motors we use solid fuel, and in the core stage, first stage we have used, second stage we have used Vikas engine, that is liquid stage, and this third stage is gaseous stage, that is cryogenic stage. So this is what regarding to the structure of GSLV students. So how many times it was launched? Make a note like this. GSLV was launched for 7 times. GSLV was launched for 7 times. All are successful. GSLV Mk3 was launched for 7 times. All are successful. All are successful. And next one is, it was initially designed for launching. It was initially designed for launching. Initially designed for launching. Communication satellites into the. Communication satellites into the. Communication satellites into the. Geosynchronous. Geosynchronous. Geostationary, geostationary, and geotransfer orbits. Geotransfer orbits. Even though if I teach orbits first, there I have to mention about PSLV, GSLV. You will get confused with what is PSLV, what is GSLV. Okay, these are interlinking concepts. Hence, step by step, I am giving you the information so that you will get a better clarity after completing these orbits and all. Okay, now first we need to go through this. What are the specifications of the rocket? What are the types of the rocket systems? Okay, friends. So that is what regarding to the GSLV. Series, what is the payload carrying capacity of PSLV? Write this payloads of PSLV also. Right there itself in the picture. Payload of PSLV is, if it is in sun synchronous orbits, 1750 kg. If it is in geotransfer orbit, it is 1425 kg. If it is in sun synchronous polar orbits, 1750 kg. 1750 kg. If it is in geotransfer orbit, it is 1425 kg. So you might have seen, you might have observed this. As the version of the rocket increases, the payload carrying capacity of the rocket has been enhanced or not? Yes. As the payload carrying capacity of the rocket has been enhanced, we can launch multiple satellites into the orbits. That is what payload carrying capacity of PSLV. Like this, you might have been confused with the GSLV Mk3. See this, friends, GSLV Mk3 is also known as LVM3. LVM3 means Launch Vehicle Mark 3. Like that also they can pronounce it, Geosynchronous Satellite Launch Vehicle Mk3, or we can call it as LVM3. This is from the ISRO website, friends. Directly from ISRO's website, we are discussing this. Make a note of that also. Next one is one more thing I want to show you is here is, so this in GSLV Mk3, how many stages it was mentioned? 3 stages. It was mentioned as 3 stages, friends. This is the place where payloads are placed. This is the payload places. And next one is, this is what means cryogenic engine. So this is the cryogenic engine stage. Okay, now, and how much capacity of engine is used in this cryogenic engine? See, we have used cryogenic engine. How much capacity here? CE 20 engine. But this stage is known as C25 stage. Why we calling it as C25 means it will be operated for 25 seconds. Okay, hence we call it as, this stage name is C25 stage. But how much capacity of cryogenic engine is used means CE 20 kilonewtons was used. And here, how many strap-on motors are there here? 2 strap-on motors are there. And middle one is core stage. In this core stage, so you can access to the information. So this in core upper stage, that is C25 stage. What is the capacity? C20 capacity kilonewtons. And next one is boosters. In this booster strap-on motors, what is the fuel that is used? Solid rocket is the fuel that is used. And next one is, in case of this, so this here we use this, what fuel means? This stage, in the middle stage, that is second stage, stage 2, we used liquid fuels. That means here we used Vikas engines. How many Vikas engines are used in this stage? L1 stage. 2 Vikas engines are used. So in this LVM3, this strap-on motors are booster straps are the first stage, and this one is the liquid phase is the second stage, cryogenic stage is the third stage. Hence total number of stages is 3 stages. Okay, now, so you can access to the information from the ISRO's website like this ones. And how many launches it has been done so far? So this, it has launched for 7 times. Okay, now, last launch is what? Chandrayaan 3. You know, and like this we have done these 7 launches, all are successful. All these launches are successful ones. So that is what regarding to this GSLV Mk3, or we can call it as an LVM3 ones. Next rocket version is small satellite launch vehicles. Small satellite launch vehicles. Small satellite launch vehicles. In these small satellite launch vehicles, so here also there will be 3 stages. This is stage 1, stage 2, stage 3, and here it is SSLV. In all these 3 stages, solid propellants are used. Solid propellant is used here. Solid propellant is used here, and here also used is solid propellant. Here it is velocity trimming module. Payload of SSLV. So velocity trimming module is there, and payload is so 10 kgs, 300 kgs, 500 kgs. All the small satellites will be launched with the help of SSLV. Small satellite, hence we call it as small satellite launch vehicles. In all these three stages, solid fuel, solid propellant is used. No strap-on motors here, booster straps here. So especially this rocket was designed for what purpose? Means for launching of small satellite launch vehicles. So don't add these payloads. So there is a question from online. So PSLV means 1750 plus 1425. Like this, don't try to use mathematics there. If it is in sun-synchronous orbits, it is 1750. If it is lower Earth orbits, it is 1425. Like that, you have to think. You know? Next one is, see, regarding the small satellite launch vehicles, as I told you that it was especially designed for what? Means launching of nanosatellites, microsatellites, and mini satellites. So it was especially designed for that. And where it will be launched? Into 500 kilometers planar orbits. And how many modules are there? 3 solid. And what is this liquid module? Liquid trimming stage means what? Means why we have introduced this trimming module means, so when we launch different cages of satellites into the different orbits, speed has to be maintained. Certain speed has to be maintained. So for different weight of the satellite, different speed will be there. Hence we have introduced velocity trimming module. If the weight of the satellite is more speed has to be maintained. If the weight of the satellite is less speed has to be maintained. According to the payload of the satellite or according to the weight of the satellite, what happens means we will maintain the speed, we will change the speed. Hence velocity trimming module was introduced in SSLV rockets. From where we are launching these SSLV rockets? Thoothukudi rocket launching station. Okay, now, and next one is, what is the benefit of this SSLV rockets? Why India is looking towards these SSLV rockets? What benefit we get regarding to these SSLV rockets? See, this operation cost becomes very less, low cost with low turnaround time. Low turnaround time means, see, once after launching a rocket, and if you need to launch another rocket, means one more launch, we have to wait for at least 1 week in case of PSLV, GSLV. But in case of SSLV, within 24 hours we can go for another launch. That is what low turnaround time means. Okay, now next one is flexibility in accommodating multiple satellites. Launch on demand facility. Launch on demand means whenever we want services, we can provide the services. Next one is minimal launch infrastructure requirement. With less infrastructure requirement, we can launch the satellites. So if you want to launch this nano satellites, small satellites, and micro satellites with the help of PSLV, so satellites will be very small in nature, but the vehicle is big. So cost of launching the satellites will be increased or not? Yes. Okay, now hence we have designed these SSLV rocket systems. Okay, now for that purpose only SSLV rockets were designed, students. What clarity on this? Make a note of this. Low turnaround time. Once again I am repeating, what is low turnaround time? In case of PSLV, GSLV, after launching one launch, so during the time of launch, huge amount of heat energy will be generated because of that basic infrastructure facility will be damaged. And we have to rebuild it, reconstruct it, and we have to go for other launch. It takes approximately 7 days of time. Okay, if it is SSLV, after going for one launch, within 24 hours, we can launch the another rocket. Like this, number of rocket launches can also be increased. With SSLV, we can go for 7 to 8 launches in a year. But in case of PSLV, GSLV, it is 1 or 2. Okay, that PSLV is too costly, GSLV is too costly compared to SSLV. What is friends? So number of launches can also be increased. Hence, when the number of launches are increased, launch on demand facility can be provided. If any country is approaching India for launching of satellites, we won't say no. Yes, we will launch. Why? Because what is the confidence behind that? SSLV rocket is there. Okay, now we can go for multiple of launches. So that is what launch on demand facility means. Is it clear, friend? Any doubt other than this? Shall we write this? Make a note of this. Yes, please make a note of this. I will explain it. Okay. SSLV rocket was especially designed for launching of nano, micro, and mini satellites. Micro and mini satellites. Thoothukudi rocket launching station. Thoothukudi rocket launching station. THOOTHKUDI. Thoothukudi rocket launching station is especially designed for launching of these rockets. It has 3 stages. In all these stages, solid fuel is used. Next one is, in SSLV rocket, velocity trimming module was introduced. That means, velocity trimming module was introduced. That is, while launching the different satellite payloads, speed has to be maintained. According to the weight of the satellite. Hence, velocity trimming is necessary. Okay, that is what. Taking key features Key features of SSLV. Key features. What are the key features of SSLV means? What is the first feature? Low cost launch. Launch cost is less. Okay, the next one is turnaround time is low. Turnaround time is low. So immediately after a launch, within 24 hours, we can go for the second launch. Next one is number of launches can be number of launches per year. Number of launches per year is 7 to 8. Number of launches per year is 7 to 8. Next one is launch on demand services can be provided. Launch on demand services can be provided. Launch on demand services can be provided. Okay, next one is minimal infrastructure is required for the launch. Minimal infrastructure is required for the launch. Minimal infrastructure is required for the launch. Okay, now. Next one is, so this is what the key features. Come out of this and write this point. All the satellites with SSLV rocket, all the satellites with SSLV rocket will be launched into the lower Earth orbits and the sun synchronous orbits. Lower Earth orbits and sun synchronous orbits. Sun synchronous orbits. Right in the bracket, 300 to 500 kilometers. 300 to 500 kilometers range. 300 to 500 kilometers range of orbits. Got clarity? Okay, so that is what the key features of SSLV rocket systems. This is also one of the operational rocket systems. Any doubt regarding this? So velocity, why? See, there is a doubt from online. Why velocity trimming module is not introduced in other rocket systems? So other rockets in PSLV, GSLV, MK3, it maintains a sufficient speed while launching the payloads of the rocket. But here, the payload of the satellites is different payloads we are using now. One payload is 10 kgs, another payload is 100 kgs, another payload is 150 kgs. Those weights are not near. Okay, and there is a huge difference. Hence, we need to maintain the velocity trimming module there. Okay, students, are you packing? No? Okay, now one more thing is there. Take heading. Sounding rockets or Rohini rockets. Sounding or Rohini rockets. So we will complete this operational rockets today, and tomorrow we go for future rockets as well as historical rockets. Sounding rockets are Rohini rockets. So for what purpose we use these Rohini rockets, and what is the specialty of these sounding rockets? See, these rockets are especially used for experimental purpose. Okay, now, if you want to do any experiment, we will do with these rockets. Technology demonstration purpose. Technology demonstration means if you develop any new technology, to demonstrate such technology, we use these Rohini rockets. Okay, now, next one is upper atmospheric studies, that is aeronomy studies and meteorological studies. If you want to study upper atmosphere, we use these rockets. And if you want to go for the meteorological studies, we use these rockets. And we won't launch satellites into the orbits with the help of these rockets. It is used for technology demonstration purpose, experimental purpose, and upper atmospheric studies, that is aeronomy purpose, and next one is meteorological studies. For only this purpose, we are using these Rohini and sounding rockets. From where we are launching the sounding rockets? Tumba Equatorial Rocket Launching Station, or we can call it as an Vikram Sarabhai Rocket Launching Station. From there we can launch it, as well as another one is SDSC, SHAR. Okay, Sri Kota. From Sri Kota also we can launch this sounding rockets. Currently there are 3 operational sounding rocket students. One is RH, that means Rohini 200. 200 means diameter of the rocket. And RH 300 MK2, RH 560 MK2. RH 200 is used for meteorological studies, and RH 300 is used for aeronomy studies. RH 560 is used for aeronomy studies. Aeronomy means what? Means upper atmospheric studies. Are you getting it? Is it clear? I am shouting, you are also shouting. Okay, so this is what regarding these Rohini rockets are sounding rockets. We'll write this in next class. Okay.